Alright, so good everyone. So today we'll be looking at three-phase diode rectifier. Okay, but before we start with three-phase, let's just see what is a rectifier and how does it work. Let's see how it works first. Now look at it. So you have, let's say you have an AC signal like this with a load. Okay, so we know that current flows like this. It flows forward, backward, forward, backward. I hope you believe that. All right, it flows forward, backward. What do I mean? I mean it flows like that: forward, reverse, backward, forward, backward. Okay. Now, a rectifier is something that will convert the current flow, instead of flowing forward, backward, to flow only in one direction. Right? So, remember this load is seeing current flow like this: forward, coming down, later, backward. Alright, so you have forward, backward. Now, but with a DC, if I have a DC there, current will flow like this only, just in one direction. In other words, we'll have something that looks like that. Right? Okay. So, now, how do I make this current that is flowing forward, backward, to only flow in one direction? That is what we are going to do. That is the essence of rectifier, to see how we can have something that looks like this, that only flows in one direction. Okay, how do we do that? Let's see. So what we do is, I need to look for a way to remove this first. Alright? So we can use one diode to do that. For now, if I put a diode here, alright, now a diode only allows current to flow in one direction, right? Now, if current flows, if I have this from here going forward, it's fine, it can go forward, right? This is AC. Now, when it is coming back here, it cannot go because this will block it. So the diode will be reverse biased. So that means what you will see from the output will look like this only, reverse biased. So it will be blocked. Now under half cycle, that it will block it like that. So you see something that looks like this, but this is not a DC. It's a DC, but it's discontinuous. Discontinuous signal. Because this signal is discontinuous, you see, right? Which is not good. Doesn't look like this, right? Okay. Now let's look for another way just to see if you can make it a little bit better. All right. Let's now see how can you do that. Let's use two diodes. Okay. But for me to use two diodes, what do I do? Now, all right. I'll see. Let me have diode 1 and diode 2. Now what do I do? So what we have to do now is we are going to now look for a transformer. All right, center tap transformer. Let's have a look like that. So we take that transformer with center tap. All right, so we connect this to this. Did you get that? All right. So now I'm going to have this. Just terminate these two here. All right. Okay. So now, we have this. All right. Now I have now two diodes. All right, with center tap transformer, so that the first, as current flows through here, forward, backward. Now here we're going to have also current that will flow forward, backward, and also here, going forward, backward. But now let's see. All right, let's check what happens to the load. All right, now the first half cycle, all right, as this AC is going forward, backward. So on forward, here we're going to have first half cycle. So this will go like that, like this, like that, and come back. All right, so that means this load, we see this current coming this way. All right, so first half cycle, I'll have that in forward direction. Right, now in the negative half cycle, Negative half cycle, let's see whether this one can go. Negative half cycle, let's see if it can go. This will block it. So on reverse bias, this will be reverse bias, so we're not going, this will not conduct. No current will flow like that. Alright? So now let's see now, in other words, I'm not going to see anything coming negative, alright, through here. Now let's see, at the same time, when you have negative, when it's reverse bias, let's see, this one will conduct, because look, it goes like that. It goes this way, it goes to the load. Oh wow. So that's like that. To the load again. So the load will now see this. Alright? So, and that continues like that. So you'll be seeing that. So now we don't have any discontinuous signal anymore. It's now a full wave. Okay, but we use data. Alright? But now, transformer, I want something that is transformerless. So instead of using the two diodes with a data transformer, let me look for another way of getting the same kind of signal. Okay? The same full wave. Now let's see. So I'm going to do, I have here 2 diodes. Now let me see if I can use 4 diodes. Now, so we have that, and then with this, now I'm going to connect this. So I need to connect that to the load. Alright, now let's see what happens. Okay, let's see what happens with that. Now, the first half cycle, remember this will be going forward, backward. So now let's see, forward, first half cycle, go like that. It comes to this point. It cannot go down because here it's reverse bias, the diode here. So it goes like that, cannot enter here, it goes to the load. Like that, now it comes back, right? Okay, so that means this load, we see the first half cycle positive. And then let's see now. Now, as this is reverse biased, as this is going negative, the negative part, so the negative part, so this will go like this, go like that. When it comes here, it cannot go down here because this will be reverse bias, so it goes, takes that way. See, like that. And then take this, take that back. Right? So that means that this, we see another waveform again, like that. Okay? So it means at the end of the day, you'll be getting something that looks like this. But it's still not yet. It's still not yet a pure DC straight line. Can you see? Can you see these places? Can you see here? So I need to look for a way, right, of covering all these places. So if I can look for a way to cover here, so that I will have something that just looks like this. You know, if I can do that, you see, then it will look a little bit just like a straight line. Alright, until I will make it to look like this. Then we get a straight line. So for me to do that, right, then I'm not going to use only 4 diodes. Now I'm going to use 6 diodes. And if I use 6 diodes, then the source voltage has to be a 3-phase. This now takes us to 3-phase diode rectifier. Okay, so let's watch out and see how a 3-phase diode rectifier works.